I'm sure you've heard about nuclear energy, but did you know there are two types? Nuclear power plants use fission, which is the process by which the nucleus of an atom is split into two or more smaller nuclei while simultaneously releasing energy. Despite being a prominent energy production method, this process uses non-renewable energy resources and results in radioactive waste. The other type of nuclear energy is nuclear fusion. In order to understand this type of energy, we must travel to space, to our very own sun. The sun utilizes naturally occurring nuclear fusion in order to produce heavier elements from hydrogen, such as helium and lithium. In extremely high temperature environments, say around 10 million degrees Celsius, and with an immense gravitational pull, free-floating atomic nuclei are forced closer and closer together. Because these nuclei are made of protons and neutrons, and thus have a positive charge, they do not want to get close. However, the combination of gravity and high temps allow this electrical repulsion to be overcome and the two nuclei can fuse. When aiming to replicate such a process on Earth, scientists would use two distinct elements, deuterium and tritium. These are both isotopes of hydrogen, meaning that they each have one proton but different numbers of neutrons. When forced together under extreme heat, these elements can collide and produce helium and stray neutrons. The products weigh less than the reactants in this reaction, so where did the extra mass go? It became energy! Because we live on Earth and not a blazing star, fusion has been incredibly difficult to replicate. However, scientists at the Lawrence Livermore National Laboratory have recently been able to achieve fusion ignition, which is a process of fusion that results in a greater energy output than what was put into the reaction. This has incredible implications for the future of energy consumption. If we can learn to produce fusion on an industrial scale, we can provide almost limitless, clean, safe, and affordable energy to meet the world's demand. Fusion produces 4 times more energy per kilojoules of fuel than fission does. Just a few grams of the reactants can produce enough energy to supply one person for 60 years. Additionally, it does not leave long-lasting nuclear waste, nor does it emit carbon dioxide or other greenhouse gases. Plus, the reactants are renewable. What does the future of nuclear energy look like? ITER is an ambitious energy project taking place in southern France and being collaborated on by 35 nations. They aim to build the world's largest tokamak, which is a device that utilizes incredible magnetic fields to confine hot plasma and allow fusion reactions to take place. With projects such as these, we can hope to one day utilize efficient fusion reactions to produce clean energy for our world.